So the identity sine squared plus cosine squared equals 1 is called a Pythagorean trig identity. And there's two other Pythagorean trig identities. But as you probably know from earlier in the semester when I would say this, I'm not a huge fan of trying to memorize things, right? I'd rather have you understand how to arrive at the other two trig identities if you were to need them, right? Rather than, trying to memorize so much stuff. So anyway, if you can remember, the most important thing that you can remember from this segment is sine squared plus cosine squared equals 1. If you can remember that, then you can get the other two Pythagorean trig identities. I have an equation. One thing that I know is legal to do when I have an equation is to divide both sides by the same thing. So let's take this equation and divide both sides by cosine squared theta. Okay, when I do that, because of the sum in the numerator, all right, I have to divide then each term by cosine squared. Okay, so I'd have sine squared over cosine squared plus 1. I should have my thetas, of course. Right, that's what I would get on this left-hand side. Well, what is sine squared over cosine squared? Right, I should recognize that as tangent squared. Right, so I get tangent squared plus 1. And what's 1 over cosine squared? Right, so I should recognize that as secant squared. Right, so that's how I get this identity down here. And of course, if I wanted to, I could rewrite this and say, well, secant squared minus 1 equals tangent squared. Right, so if I ever saw tangent squared in a problem and I wanted to find a replacement for tangent squared, I could replace it with secant squared minus 1 if that helped me. Okay, so you try the next example by dividing both sides by sine squared x. So pause the video, give it a try. So that would result in 1 plus cotangent squared. Cosine squared over sine squared is cotangent. And then 1 over sine squared is cosecant squared. All right, so that's the other identity down there. So let's try using these to simplify expressions. First example is pretty easy. Why don't you try that? All right, I have something I can replace with its equal. And then I just have to simplify. All right, so I replace the expression 1 plus cotangent squared x with its equal, which is cosecant squared x, times sine. And then I can remember that sine is actually 1 over cosecant, right? So I'm going to replace sine with its equal, right, which is 1 over cosecant, right? And then this can cancel and leave me with 1 factor of cosecant x. All right, so the next one, why don't you pause the video and look at what you might plug in for maybe tangent squared, right? Or you could substitute something in for cotangent squared or for cosecant squared if you want. All right, so you're going to see that on a lot of these problems. There's multiple ways to do the same problem. All right, so pause the video and give this one a try. Okay, so I decided to go this route where I replaced cotangent with its, I'm sorry, I replaced cosecant with its equal of 1 plus cotangent squared. Don't forget to distribute the negative, right? And then in the numerator, I'm left with just secant squared. And in the denominator, I have to distribute the negative, but the cotangent squareds will zero out, and I'll have minus 1. So rather than writing my answer like that, the correct way to write my final answer would be negative secant squared theta. Okay, so next example. If I had that radical expression and I wanted to replace x with 5 cosecant theta. All right, so if I were to square 5 cosecant theta, I would get this. Cosecant squared theta. All right, what I want you to do is factor a 25 out of that expression and then look and see which of those identities helps you out. All right, so pause the video and try that. Okay, so once you factored out the 25, you were left with cosecant squared theta minus 1. That can be replaced with cotangent of theta. Now, because this is a product, I can take the square root of each term. All right, if I take the square root of each term, I'm left with 5 times cotangent theta. This is actually something you do a lot in Calc 2, and I know a lot of you aren't going to Calc 2. Most of you aren't going to Calc 2, in fact. But again, this is a great exercise in getting used to an incredibly important math skill, which is substituting anything for its equal.